The Earth may seem massive and awe-inspiring, but it's only a speck in the vastness of the cosmos. Technology has enabled us to explore this great unknown, sending rockets and satellites into space to uncover the mysteries that lie beyond our planet. Our curiosity is driving us ever onward, with each new discovery inspiring us to uncover more. We long to unlock the secrets of the universe and explore its infinite depths. But how do we do that? Well, the Voyager spacecraft have been sending us valuable information to process. However, things haven't always been so seamless. For the past couple of months, we had no contact with the Voyager, and after months of silence, it's back with an unexpected discovery. Join us as we get to the bottom of what happened and what this new discovery means for the future of humanity. But before we dive into that, let's take a look at the Voyager mission as a whole, how it all began. The launch of Voyager 1 and Voyager 2 was an event that would forever change the course of history. On August 20th, 1977, Voyager 2 launched off into space, its mission to explore the vast reaches of our solar system. But this was only the start. Shortly after it left Earth, NASA made history by capturing a picture of both the Moon and Earth in one frame. The Voyager mission's primary purpose was to explore the outer planets of our solar system, but it also had a secondary goal: to send back data about the stars and interstellar environment beyond. To accomplish this, the spacecraft were equipped with sophisticated instruments to monitor their surroundings as they traveled through space. These instruments have allowed us to collect information on magnetic fields, particle densities, radiation levels, and even the properties of interstellar clouds. Voyager was also equipped with a unique communication system to send data back to Earth from deep space, a system critical for understanding what Voyager is seeing as it passes by planets, moons, and stars. Voyager 1 followed its sibling closely, launching on September 18, 1977. With both spacecraft on their way to explore and document our corner of the universe. A journey like no other was beginning, one full of discoveries that would astound us. The mission promised to be extraordinary. It was a journey to uncover the secrets of our solar system and delve deeper into what it had to offer. The future looked bright for Voyager and its mission ahead, and no one could have expected the abundance of information this project would bring us in the decades that followed. The mission had been perfectly plotted out, despite the common assumption that our solar system is round. It's not. Instead, all the planets orbit in an irregular oval, and there are only certain times when the planets align in a way that makes space travel efficient. August and September of 1977 was one such window, a rare opportunity when all the planets along Voyager's journey would be in its path. This alignment meant the spacecraft wouldn't need to deviate much from its route, making the mission both possible and successful. It was truly a remarkable moment in history. The stars and planets seemed close enough to touch as the $865 million probes left Earth and sped into deep space. In a single year, they had reached Jupiter, defying expectations and sending back an astonishing 4,000 images of the gas giant up close. 2 new moons and an additional ring had also been discovered, leaving scientists in awe. It was clear that the mission had been incredibly successful, and all the effort put into preparing these probes was worth it. With every moment, they sent back more information about our solar system, small glimpses of things we were only beginning to understand. But with each new discovery, things became even more extraordinary. Who knew what the Voyagers would find next? The possibilities were infinite. One of the most notable discoveries was when Voyager 1 captured a breathtaking image of Earth from 11.7 million kilometers away. This was the very first time a photograph of both Earth and the Moon had been taken from such a distance, providing true insight into how the Earth and Moon come together as one unit, something we'd only been theorizing about until then. To think that this box of wires and metal hurtling through space at immense speed was able to take such an incredible photo from over 11 million kilometers away is simply mind-blowing. It's remarkable that we, as humans, have been able to create something so amazing and advanced that can accomplish such feats. On March 5, 1979, Voyager 1 took its first picture of Jupiter from 57.6 million kilometers away, a significant achievement in itself, but this was just the beginning. On March 9, 1979, volcanism was discovered on the Galileo moon after analyzing a picture captured by the probe. This discovery was one of the first times it was even thought possible for volcanism to occur on a moon. Around this time, we first lost contact with Voyager 1. It was a very scary moment for everyone at NASA and for the world. After all the time, resources, and dedication that had gone into the mission, the idea that something could go wrong was nerve-wracking. It was something that hadn't happened before, but NASA worked day and night to reestablish contact, and eventually, they succeeded. Just when we thought things couldn't get crazier, on November 11, 1980, Voyager 1 had its first flyby of Titan, Saturn's largest moon. The data and images sent back to Earth revealed a world far more complex than we had ever imagined. One of the most significant discoveries was that Titan was not as large as originally thought. Scientists had previously estimated Titan's size to be between 6,000 and 6,500 kilometers in diameter, but Voyager 1 showed that it was actually only 5,150 kilometers across, about 25% smaller than originally predicted. Voyager 1 also revealed a mysterious atmosphere on Titan that was 10 times thicker than Earth's, containing nitrogen and a variety of organic compounds, hinting at the possibility of life on Titan. The probe also found methane lakes and seas on Titan, making it one of the most Earth-like objects in our solar system. Voyager 1's flyby of Titan was a monumental success, showing us that there was still so much to explore in our own solar system. The spacecraft would go on to reveal the true largest moon in the solar system. Voyager 1's flyby of Ganymede on June 5, 1979, was a significant moment in our understanding of this moon. Before the flyby, we had very little information about Ganymede's appearance or its size, which was estimated to be between 3,000 and 5,000 kilometers in diameter. Voyager 1's close-up images revealed an icy surface with extensive cratered terrain and showed that its size was much larger than previously thought. In fact, it is the largest moon in our solar system, at 5,268 kilometers in diameter, just slightly larger than Titan. The pictures also revealed a unique geological feature called groove terrain, narrow lines and ridges running parallel to each other in the moon's icy surface. Scientists believe this was caused by a process called diapirism, where warmer material from Ganymede's interior rises and breaks through the cold, brittle ice crust. By this point, it was clear that the billions spent on this project weren't for nothing. With each new discovery, the Voyagers continued to send back valuable data, showing that they were more than capable of venturing beyond our solar system. Eventually, the plan was to let them continue into interstellar space, should they make it there, to get a true look at what lies beyond our solar system. On November 12, 1980, Voyager 1 made its closest approach to Saturn, coming within 21,000 kilometers of the planet's cloud tops. During this encounter, the probe revealed an incredible world filled with swirling colorful clouds, powerful storms, and icy rings stretching for thousands of kilometers. Nearly a year later, on August 25, 1981, Voyager 2 followed its companion's wake. On January 24, 1986, Voyager 2 made its closest approach to Uranus, revealing an icy world filled with remarkable features, including blue-green clouds and a complex system of narrow rings. The probe also discovered two previously unknown rings, the Epsilon and Delta rings. The data sent back revealed a world far different than imagined, with Uranus having the coldest atmosphere in our solar system and an enormous magnetic field tilted at an odd angle. On February 14, 1990, Voyager 1 captured the iconic family portrait of our solar system, a mosaic of 60 individual frames showing 6 planets and their moons, with the Sun as a tiny in the lower right corner. By February 1998, Voyager 1 had outrun Pioneer 10, becoming the most distant human-made object in space. In an incredible feat of engineering and exploration, Voyager 1 pushed through interstellar space in August 2012, followed by Voyager 2 in November 2018. Voyager 1 became the first human-made object to reach interstellar space, crossing beyond the heliosphere, the bubble of charged particles surrounding our Sun. In November 2018, Voyager 2 became the second spacecraft to reach this region, having traveled over 41 years and 18.6 billion kilometers from Earth. Since then, both spacecraft have continued their journey, sending back groundbreaking data from the far reaches of space. In March 2019, Voyager 1 detected a faint hum in interstellar space, made up of low-frequency radio waves caused by turbulence in the interstellar medium. This discovery could help scientists better understand how galaxies form and evolve. Voyager 1 has also observed lightning strikes in Jupiter's atmosphere and studied how solar winds slow down at the edge of our solar system. The data surrounding plasma and interstellar medium has become invaluable to our understanding of space. But even as the spacecraft continue their journey into the great unknown, communication with them has grown more difficult. The further they travel from Earth, the more challenging it becomes to maintain contact. In fact, as of 2024, Voyager 1 is still communicating from more than 23 billion kilometers away. But here's the twist. After months of silence, something unexpected has occurred. A mysterious new discovery. For over 2 months, Voyager 1 had been silent. Scientists feared that the spacecraft had finally succumbed to the harsh conditions of space and that it might never contact us again. But just when hope seemed lost, the spacecraft sent back a signal that left everyone stunned. The transmission revealed something far beyond our expectations. A previously unknown form of cosmic radiation. The intensity of the radiation was unlike anything ever detected before, and it appears to be coming from the farthest reaches of space. The data collected could change everything we know about the universe and our place in it. It may even shed light on the nature of dark matter and dark energy, two of the most mysterious forces in the cosmos. So, what does this discovery mean for the future of space exploration? First, it's a reminder that even the most advanced technology we create is vulnerable, especially when pushed to its limits. But it also speaks to the resilience of human ingenuity, the determination to continue seeking answers, even when the odds seem impossible. The future of humanity's exploration of the stars is uncertain, but one thing is clear. We are constantly pushing the boundaries of what's possible, discovering things we never thought imaginable. The next frontier is waiting for us to explore, and the Voyager mission has shown us that there is still so much to discover about our universe. Whether we are sending new missions, developing new technologies, or studying the data that has already been collected, the future of space exploration is boundless. And as long as we continue to learn from missions like Voyager, the sky will never be the limit. It will be only the beginning as Voyager 1 and 2 continue their incredible journey through the vast expanse of space. Their discoveries have not only expanded our scientific understanding but have also sparked philosophical questions about humanity's place in the universe. With each new signal, each new data transmission, we are reminded of just how fragile our existence is, yet how resilient our curiosity can be. These spacecraft are more than just pieces of technology. They are symbolic messengers carrying humanity's desire to explore the unknown. The discovery of cosmic radiation by Voyager 1 raises the stakes for future missions. If this new form of radiation is truly as intense as the preliminary data suggests, it could imply that our understanding of space's fundamental properties is incomplete. The implications for astrophysics are immense. Could this radiation provide a clue to the elusive nature of dark matter or dark energy? Is it possible that we are on the brink of uncovering new forms of matter or energy that defy everything we know? In addition to scientific breakthroughs, these missions also carry a cultural legacy. Both Voyager spacecraft carry golden records, a collection of sounds, images, and music meant to represent the diversity and creativity of life on Earth. They serve as a time capsule, a potential message to any extraterrestrial life that may encounter them long after humanity has moved on. The contents of these records represent the ultimate in human hope and optimism, a desire for connection, a wish to be remembered in the cosmos. It's an idealistic gesture, but one that speaks to our deepest instincts to reach beyond ourselves. Despite the immense distance that separates us from Voyager 1, the spacecraft continues to offer glimpses into the farthest corners of space, providing information that will fuel generations of scientists, engineers, and thinkers. The data it sends back is often ambiguous and incomplete, but it's through interpreting these fragments of information that we continue to build our understanding of the universe. As technology advances, we may one day find ways to communicate more effectively with these spacecraft, reestablishing a closer connection with these distant explorers. Looking forward, the future of space exploration is promising. The success of the Voyager mission has paved the way for more ambitious missions, including the possibility of human travel beyond our solar system. While the idea of sending astronauts to another star system remains a distant dream, it's not outside the realm of possibility. With advancements in propulsion technology, we may one day be able to send humans on journeys that span light years, opening up entirely new chapters in our exploration of the cosmos. Until then, the Voyagers will continue to be our eyes and ears in the vast, unexplored frontier. As we continue to monitor the Voyager's progress, it's important to recognize the profound impact these missions have on humanity's collective imagination. Every new discovery not only expands our scientific knowledge, but also enriches our cultural understanding of space. The Voyagers have taught us that exploration is not just about gathering data. It's about fostering a sense of wonder and curiosity that transcends borders and unites us as a species. Moreover, the data coming from these spacecraft is providing valuable insights into the very fabric of space itself. From understanding the structure of the interstellar medium to mapping the boundaries of our solar system, the Voyagers are unlocking secrets that could reshape our theories of astrophysics. In particular, their observations of solar wind interactions, cosmic radiation, and the distant reaches of space give us clues about the behavior of matter in extreme conditions, potentially paving the way for breakthroughs in fields like quantum mechanics and high-energy physics. Looking ahead, the Voyager missions underscore the importance of long-term thinking in space exploration. These spacecraft were launched with the expectation that they would contribute to humanity's knowledge over decades, and their longevity continues to prove the value of visionary scientific investments. As we push further into the cosmos, the lessons learned from Voyager's success will guide future missions and inspire generations of explorers to come.